Hi friends, this is the fourth video of the series of KSET 2022 Organic Part 2 consisting of question number 50 to 65. Actually this video has been slightly delayed, so I'll try to cover up the next videos as soon as possible. So in this question here, they asked us to identify a reagent for this conversion where ether is converted to alcohol plus alkane. So in this you have to know that you have to find such a reagent that will reduce this to alcohol and the alkane group or benzyl alkane or toluene. So if you take here we have DDQ which structure are drawn here, which is 2,3-dichloro 5,6 dicyano 1,4 benzoquinoline, or which is a DDQ. Lithium aluminum hydride, hydrogen in presence of palladium, HCl and HI. Whenever you have HI reacting with ether, you will get one alcohol for sure, but we will get a halide. So this cannot be an answer. And whereas if you take lithium aluminum hydride, it will completely reduce this to, even this will not be as toluene, it will be converted to cyclo compound. So this cannot be, lithium aluminum hydride should not be there. So automatically option 1, option 3 and option 4 gets deleted. So only possible answer is option 2. So now next question is a suitable reagent combination to carry out the following conversion. In such cases, I'll suggest you, if you are not aware with all the conversions, then you may ignore this, because here they are not given the reaction conditions. They are asking which reagent can be used for to get a suitable product. So in this case, based on the answer given in this reference, it is answer C. But still, it is difficult to predict and explain on what is the conversion, how does it takes place. So I would like to suggest you, if you are well versed with all the reactions and in which condition which reactant will react to give what kind of product, then go forward with these questions. Unless, then avoid these questions, or I would suggest you to go to the book of Claydon and Caractacus for such more reactions. So now here, the selective reagent for cis hydroxylation of cyclohexane to cis cyclohexane 1,2-diol. Please remember, whichever reagents are mentioned below will give you diols, but they have specifically mentioned cis. So there are only two cases, that is OSO4 in presence of water and KMNO4 in presence of water. Remaining two will give, these two will give, but it is in form of trans. So alkaline KMNO4. Here you will get a trans product rather than cis. So only option is 1% KMNO4 followed by hydrolysis. Here I have shown the reaction, how it takes place. So other option is, if they are not mentioned, if you know, it should be knowing it is OSO4 in followed by hydrolysis. Now let's go to the next question. This reaction is the best example of, here they have to find a bond. So I've shown the possible electron transfer. See where it is moved here. So here you have double bond. From here, double bond is going to form a bond here. A bond is formed here, and the one which is there is shifted. So here the numbers only electron transferred, means bond, there is no formation of additional bonds. Only formation of additional bonds without breaking the structure. So it is electrocyclic because you don't add it to something else. It's getting interchange within itself. It cannot be sigmatropic because the bonds involved as pi bonds. If the bonds movement involved is sigma, then it is sigmatropic. The cycloaddition is definitely not the answer, because cycloaddition means it should have two, and N reaction is type of cycloaddition, so it is definitely not the answer. So for this particular question, the answer is B. It is based on pericyclic reaction, so you should be knowing the different concept of pericyclic reaction to answer this question. So the next question, which of the following pericyclic reaction is thermally allowed? Please kindly remember that for thermally allowed reaction means it should be 4n plus 2 pi system. So, and all should be in symmetry. Here see, means what pi 2 refers means 2 electrons. If they mention pi 4 means 4 electrons. It is like pi 2s means 2 electrons in symmetry plus 2 electrons in symmetry. It will be 4 electrons, but it will not satisfy this rule. So this cannot be answered. Here 2 electrons asymmetry. If it comes as asymmetry, neglect this. Both are 2 electrons in asymmetry. So it cannot be. It is again become 4. Here it is 2 pi 2s and pi 4a. One is asymmetry, so this cannot be feasible. Last option is both as pi 2s and pi 4s. So this is the one because both are symmetric and they have 4 plus 2. That will have 6 for satisfying this rule. Now, which of the following is more reactive compared to benzene towards electrophilic substitution? So here we have given the sequence. You have to note it. Pyrrole is more reactive than furan, then thiophene, then benzene. This is based on the concept of more availability of electron within the structure, and as you all know, these all three have heteroatoms, so it is comparably more reactive compared to benzene. Here they have given both pyrrole and furan is more reactive. Thiophene is not there, so that will not come. And in case of pyridine, it is a similar structure of benzene, which one place with replaced with nitrogen. In that case, the nitrogen's lone pair are involved in within the electron cloud, so it is not so reactive. So both pyrrole and furan, this is the correct answer. Otherwise, if you remember this sequence, pyrrole is maximum, then furan, then thiophene. So now the nitration of furan can be achieved by the following nitrating agent. So since this is the reactivity, in case of nitration, the sequence will be exactly opposite. Means pyrrole will require very mild agents to get nitrated, whereas benzene is require highly strong agent like nitrogen mixture. So in this case, fuming HNO3 is not possible. In case of if you are using ACONO2, is also not possible because you have to take it at a very low temperature of minus 10 degree to 20 degree. This is all nitrating mixture, so this is also highly concentrated, so only option is this one. So indole undergoes electrophilic substitution mainly at. So whenever you take the resonance structure of indole, they will be having around 13 to 15 resonance structure, whereas where in case you will get at position 2 and position 3, but they are asked mainly means which will give major product. So when you are considering the substitution electron with C3 carbon, you can observe the second stage. Here we have a benzene structure, aromaticity is retained, but in case of if you take C2, the benzene aromaticity goes off. See, here we have 6 pi, here we have 4. So it has to be 3. Whereas if you take consider 2, you will get a product. But since this aromaticity is been reduced, so major product is at position 3. For this understanding the positions, you should understand the nomenclature of heterocyclic compounds by multi-cyclic compounds, because if you go for other compounds you will get different ways. So I'll suggest you to go to the heterocyclic chemistry books. So next question is here. The compound with the molecular formula M by Z is 12 is transparent to UV spectra, and for IR it will give 2 bands at 2940 and 1464. In PMR means proton magnetic resonance or 1H nuclear NMR, it gives only a singlet at 1.52. So remember one thing, since it is mentioned that it is not visible, it cannot have what we say, a double bond or any sort of double bonding. Here we have all, this one is having double bond, so automatically it goes off. Now what remains is 1, 2, 3. Now what I mentioned, it gives 2 bands. Let's take this point later because it may not be required. He say for NMR is getting singlet. If you take octane or even heptane you will get 5 peaks, whereas if you take octane you will get 4 peaks. So only possible is cyclooctane because it is a cyclic structure and it will not have any kind of visibility in UV spectra. So the answer is cyclooctane. So the expected apparent mass of the metastable ion produced when ion having 77 M by Z value of 77 is decomposed to loss of acetylene to get M by Z value of 51 will be. For this there is a formula, you should try to remember it. M dash means apparent mass is equal to M1. Here M1 is almost a smaller one, please remember that, square divided by M2. Here it is 51 into 51 divided by 77. You will get an answer is 33.7. But the only option what we have of 33 is 33.4. So this is the correct answer. In case if they give other options related like 33.1, 33.4, 33.5 and 33.7, then it is expected you should take marks 33.7. Since here they are not given any answer close to it, then it is not an issue. Now, which of the following ketones will absorb IR near 1750? So this is a direct concept based question and the answer is 2-methyl cyclopropanol. Others, I expect you to see what is know at least the basic ones, on that you can take a guess. Now here, so this is a direct concept based question. If the base present in RNA but not in urine, DNA, so it is uracil because the remaining 3 are present in DNA. Now the complete hydrolysis of cellulose will give D-glucose. These are some direct concept based questions, you can directly go through it. Predict the number of double bonds present in linoleic acid. This is 3. Actually there are some oils that you should know the name and their number of double bonds present. It's like around 7 to 8. It's expected that you could know because those are the normal use oils, and if you want I'll share it in the coming videos about what are the oils, the structures, chemical formulas. Definitely I can't write the structure because it is like C17H. So carbon is 17, then followed by double bonded carbons and all those. I'll give a compact structure and number of double bonds present. So with among the spectra which can give bond length, please remember rotation means IR, vibration vibration, FTI, NMR. NMR will never give, it will only help us to identify the type of atoms present, like if they are having similar range means they are in the same kind of bonding conditions or different bonding conditions. In case of FTIR, stretching vibrations, based on vibrations of the functional groups present, it will help us to rotate. In case of vibration, it is same as FTIR. Rotation is specifically rotating of single molecule. So this is the end of this video. So in next 2 videos you will be completing this series of 6 videos. That is next video is physical chemistry and followed by physical chemistry part 2, which I will be uploading very soon. So after this I would like to know what you would want me to cover. Please give your suggestions in the comment box and please do like and subscribe my channel. Thank you one and all.